Okay, so while I'm on that question, I decided I'm just going to finish out part C as well, just to have a little talk about that and show you a sample answer for that. Sometimes with these questions, they will ask you to just discuss using notes and sketches something related to improving the U-value or methods of retrofitting and things like that as well. I have given you those notes. I gave them to you last Friday, I think. So it's worth having a little read through that. But to be honest, a lot of it is just common sense as well. We're going back to thermal bridging, condensation, and all those things can help, right? I'll just look at the question there first. In the past, many dwelling houses were built using hollow concrete blocks as outlined in 5A. So using this above. Discuss two disadvantages of this type of construction, and using notes and freehand sketches recommend a preferred external wall type suitable for a contemporary house. So basically we're being asked what are two bad things about using this type of wall, and then recommend a better type of wall. So again, there's so much you can speak about here. You can talk about anything to do with your fifth year theory on walls, like soundproofing and things like that. It wouldn't be as good as soundproofer, but you can also go into what we've spoken about this year: thermal bridging, condensation, high costs of oil because there's no insulation. The high cost of oil means you're going to be using a lot of oil, which also in turn goes on to carbon emissions. You can pick any two of those. I always say high cost and carbon emissions are two things you could always talk about. Sample answer I've done up here, I'm going to read through with you. It's just a page and a half of bullet point notes, and maybe it'll help you understand what's been asked. So I've written two disadvantages of using this type of wall construction are as follows: thermal bridging and extra cost on heating. Thermal bridging: this wall has no insulation, therefore a huge amount of heat will escape through the building envelope. This will make it very uncomfortable for the inhabitants. The fact that there will be so much thermal bridging evident here means that condensation is very likely to occur. This can be unsightly, damaging to the structure, and also bring health concerns. There's that first part done. The second heading, extra cost on heating. Due to the fact that heat can escape so easily through this wall, the heating will need to be turned on for longer periods of time. This means that more fuel will be used, resulting in large fuel bills. Having the heating on for large periods of time also means that there will be more cost on the maintenance of the heating system. Simple. That's those two headings done. Now the question also asks us to recommend a wall type. All you have to do, I've recommended a simple basic cavity wall. Any wall that improves that old wall which was shown in the question. So our preferred wall type to use here is simply an insulated cavity wall. Very, very quick and simple sketch. Label all the parts. The cavity adds thermal mass to the wall, and the insulation helps to reduce heat loss, therefore reducing bills and increasing comfort. That's that part of the part C of the question done for your 15 marks there. Like I said, there's so many things you can talk about. If you people read that question first, you mightn't be sure if you know the answers, but you can talk about lots of things. I haven't even mentioned carbon emissions there, which you could bring in as well. You don't need to go into massive detail in that. It's only a part C. It's worth 15 out of 60 marks. But at the same time, just make sure you cover yourself and it's well laid out and you get your couple of points across as to what you're talking about. And if it asks for sketches, obviously make sure you include a sketch. Alright.